So here we're demonstrating Archimedes wind turbine along with solar hybrid power generation and utilization to the DC load. So the main application of this project is from the wind and solar, the generated voltage will be stored into this battery pack. We are using 12 volt 2 amp battery. So coming to the battery pack ratings, we are using like 4 volt 1 amp battery, 6 numbers. In that 3 are connected in series. So we'll get 4 volt 12 volt 1 amp, and this is a 12 volt 1 amp. These two are in parallel. We'll get 12 volt 2 amp DC output. So here we are providing the hybrid, nothing but one is wind through this Archimedes wind turbine mechanism, and there is a solar. This is attached to the dynamo, so which has a gear ratio of 1000 rpm to 2400 rpm, means it will increase the gear ratio speed. And this is a 12 volt DC dynamo of 20 watts. So the output will be given as input to this battery pack through this charging circuit. Same, getting power supply from the solar panel. So we are using 12 volt solar panel, and the maximum voltage is of 10 watt solar panel of power, and 17.4 is voltage maximum we are going to get, and the current is 0.58 is amps, and open circuit voltage is 21 volts maximum voltage. So this output is input to this charging circuit. So coming to the charging circuit, there we can see the commonly IC and filter and diodes along with the resistor and LED. So this IC is the DB107, which is inbuilt, consists of 4 diodes which will acting as a bridge rectifier. So though we are providing the DC input either from the dynamo or else solar panel, here this will act as a polarity corrector, means if we accidentally connect this in reverse polarity, in reverse direction, then it may damage the battery pack or the source if is a reverse polarity connected. So in order to rectify that polarity corrector purpose, we are making use of this DB107 IC, to which will rectify that to the main plus minus and output filtration. And these two diodes will acting as a unidirectional current flow, means if the battery is fully charged, then this will become the high potential, and if there is no sunlight or no wind to this turbine, then those will be the low potential. Then these diodes will block the current flow from the battery to the sources to protect the sources whenever the low potential got occurred from that one, and LED indication to show the power availability from the respective source. As we can see the low lighting on the solar panel, that's why we're getting the low intensity from this LED indication. And the next third source for the battery charging is 230 volts grid. From the grid only directly we can charge a battery pack through this transformer, which is used to step down the 230 volts AC to 12 volts of AC. And same here, this is rectifier, filter and 2 diodes, same for unidirectional current for purpose. And before demonstration, we should keep the battery under charging. If the sunlight or wind is not available, keep the battery charging to the transformer. It will take around 3 to 4 hours to be fully charged from the grid. So if the sunlight is available, so it will take 5 hours from the solar panel and 2 hours from this wind turbine. So if all sources are available, within 30 minutes only the battery will get fully charged, as we are going connected the 3 sources in parallel. And once we battery charged, we can utilize that to the DC load by switching on that. So we are using the 3 watt 12 volt DC load here. And the next, coming to the kit output, just on the kit. So once a welcome message displayed, and the battery voltage is continuously measured from these voltage sensors. So each voltage sensor consists of 2 resistors, which is nothing but potential divider, that is a 10:1. So the purpose of this voltage sensor is to measure the 12 volts by our microcontroller, which is operating voltage is 5 volt. So we need to make this voltage which can be easily safely accessed by our microcontroller. That's why we are dividing that using these 2 resistors, which will acting as a potential divider. The voltage will be divided in 1:10 ratio. If the output from this voltage sensor is 1 volt, then in the programming we are applying the formula of 1:10, that is 1 volt into 10, that is a 10 volts is the input to this voltage sensor. So when you are getting the 12 volts from this one, the output from this voltage sensor is 1.2, and in the microcontroller we apply the formula of into 10, so we'll get the 12 volts. So that will be measured on this display on the 16:2 LCD screen, which was connected pin number B2 to B7. And the voltage sensors are connected respectively A0, A1 and A2 directly to this microcontroller. We are using PIC16F73 microcontroller. So here whenever we applying the more lighting on the solar panel, as we can see, the voltage will get increased, and when we close this, then the voltage will be drops. So once we place this wind turbine under the air input, the ceiling fan, బయట పట్టుకున్నా బయట. So on the LCD we can see the generator voltages. So whenever this dynamo rotates, means wind turbine rotates at a ratio of 1000 rotations per minute, then the generator voltage will be 14.5 maximum voltage, which is sufficient to charge our battery.